in this session, we'll talk about the class ranges, number of networks, and number of hosts, and that those belong to class A, B, and C. So, by end of this session, you will understand why class A provides large number of hosts, wherein class C provides more limited number of hosts when we use class C IP address. So let's jump in and understand the concept. So in this segment, we'll talk about IP classes and the number of networks and hosts that they can hold. So we, if we look at the classes, so class A, if we talk about the octet format, it is n.h.h.h. So class A is divided here as we discussed earlier. All ones if we use, it is going to be 255, and the host portion if we make all zeros, it will be 0.0.0 in the decimal format. Class B, same way, two network portions, two host portions, and in class C, three fields are network portion and one field is host portion. So if we look at the three classes, class A, class B, and class C, the class A network is divided here, the IP is divided here. So this is the network portion and this is the host portion. Class B, the IP is divided here. On the left side, the first two fields are the network portion fields and the other two are the host portion fields. Same thing goes with class C. The first three fields represent the network portion and the last field represents the host portion. So network portion, as we discussed earlier, is denoted as 1. So if I make all the bits in the network section as 1, it's going to give me the subnet mask as 255.0.0.0. Same thing with class B. I'm going to get a subnet mask of 255.255.0.0. And in class C, the first three fields are going to be 255 and the last host portion field is going to be 0. So if you look at the number of host bits here, class A is having the large number of hosts which can be accommodated, but the number of networks is small as compared to other classes. Same with class B, it is a medium sized network as there are only two fields or two octets used for the host portion, and in class C the last field is the host field where uh, a small number of hosts IPs can be accommodated. So that's where it is a small network as compared to class A and B. So on a high level, class A is a large size network, class B is a medium size network, and class C is a small size network. So let us understand the number of hosts or number of networks that class A can accommodate. So class A, the octet format is like this, n.h.h.h. So here number of bits in the network portion is 8 and number of bits in the host portion is 24. So each field has 8 bits. So 8 threes are 20, 24. So Now to calculate number of networks, there is a formula 2 raised to n minus 1, wherein n represents the bits in the network portion. So here 2 raised to 8 minus 1. So minus 1 is the priority bit for class A. So here it becomes 2 raised to 7, and 2 raised to 7 is 128, minus 2 is because 0 cannot be used and 127 cannot be used in class A. So that's why we are subtracting the number by 2, and that's where we get 126 networks in class A. And let us calculate how much hosts each network can accommodate. So 2 raised to n minus 2 here. So this number is the number of host bits, that is 24. So 2 raised to 24 minus 2 gives us the number as this. So these many hosts can be accommodated within each network. So we can have 126 networks. So each network can hold up to these many hosts. So that's the reason class A can have 126 networks and these many hosts. So let's calculate for class B. So here, if we look at the octet format, it is n.n.h.h. It means first two fields, that is 8 2s are 16, and two net host fields, 8 2s are 16. So total network bits are 16 and host bits are 16. So calculating the number of networks, so 2 raised to 16 minus 2. So it's going to be 2 raised to 14, and the value comes out to be 16,384. Now number of hosts, here it's going to be 65,534 hosts per network. So friends, one thing to note here is, here we are subtracting 2 in the power section of this 2, but here we are subtracting 2 from the total value. Okay, so for any network, you take class A, B, or C, any network, the first IP of the network and the last IP of the network cannot be used. And that is the reason we subtract this by 2, so that intermediate IPs are the IPs which are usable. So here we can have 65,534 hosts within each network. So 16,384 are the number of networks, and within that each network we can have these many number of hosts. So let's see the summary here. So 16,384 networks and 65,534 hosts per network can be accommodated in class B. Coming to class C, now it would be the exactly opposite scenario of class A. So here the number of networks in class C, we are subtracting 3 here because 3 is the priority bit for class C. So 2 raised to 21, these many number of networks. And if we want to calculate the hosts, so 2 raised to 8 minus 2, total 254 hosts can be accommodated within each network. So in a nutshell, Class A has large number of hosts per network, and here in class C has more number of networks, but the number of hosts per network is maximum 254. So in the next section, we'll be talking about network and broadcast address. Thank you.